Hello, welcome to Process Automation lecture series for BTech students. So today, as a continuation to basic PLC programming, today we are going to start with the PLC programming where we are going to discuss mainly what is meant by latch or latching and how we are going to use a latching while implementing a ladder diagram. So basically, when I say latching, but before that we have a three uh, major points which we have to be in mind while going for the PLC program. So first one is a memory, second one is a latch or latching, and the third one is a trigger. Third one is a trigger. Okay. So out of which today we are going to discuss a latching. So what is meant by latching? If I want to draw the latching, how the latching will perform, so with the help of push button, so I can draw it like this. So here it is positive P and negative, and here I'm going to draw two push buttons. Here it is normally open, then it is normally closed, and this is the motor. This is the motor. And now when I am going to press this normally open, that is, I can say it is a start button and it is a stop button. Okay. So when I press the start button, the button is used to connect the circuit, and when the circuit is completed or connected, the supply flow from positive to negative through the motor, and motor will on. But it is a push button, so when I am releasing the pressure, when I am releasing the push button, the connection is disconnected. Basically the connectivity is disconnected and motor will be off condition. But what I want in any application, when I press the push button, that is the start button, my motor will continuously on till I press the stop button. Okay. So for that reason, for in that particular case, what I have to do, I have to continuously give a supply. I have to continuously provide a supply to the motor. So for that, what I can do, in a parallel, I will connect one coil. I'll connect one coil. So basically, when I'm pressing the start button, connection is established. When the connection is established, this coil is energized. And when I'm removing the pressure from start button, okay, the motor will on through this charge which is stored in the coil. So I can say that this is my latching concept. Okay. And if I want to draw it in the form of ladder diagram, I can say that this is my positive and negative. Okay. Then this is my normally open start button, normally close stop button. This is my motor as an output. So it is a start, it is a stop, and to latch I am going to use a motor connection here in parallel with the start button. So basically, if I am providing a logic 1 here, so normally open became close. Okay, it became close. then supply flow from start button. Stop button is already in closed condition, so it will flow through the motor and motor will on. But when I am releasing the start button, it will disconnect. Okay, but the supply will be from this parallel link, from this parallel link. So that is nothing but the concept of latching. Now if I want to implement latching, or if I want to implement a ladder diagram using a latching, so basically just remember, if I say here we have a b two input, y0 y1 are two output, where a and b are push buttons. A and B are push button. So when I say it is a push button, the working of push button is when you press push button, there is a connection, but when you release, the connectivity is disconnected basically. Okay, so for that we have to use a latch. We have to use a latching concept. So here we have a two input and two output. So 0 0 0 0, 1 0 1 0, 0 1 0 1, 1 1 0. Okay, so if I want to implement this, what I'm going to focus basically the output having a value 1, having a value 1. So that I am going to implement this. So basically a ladder diagram here, we have a two output, that is y0 and y1, y0 and y1. So here if I say this, so y0 is 1 when a is 1 and b is 0. So I can say that when I say 1 logic, it will change the state. So basically before applying a 1, my state is normally open for a, but in case of b it is normally closed. It is normally closed and it is connected to y0. It is connected to y0. Now when I am releasing the button A basically, which is firstly which is 1, but when I am releasing a button A, it will 0 and your output will off. But मुझे क्या चाहिए? I want my output is continuously on. So what I am going to do? I am going to use one input as a output, that is y0. So it will be continuously on. It will be continuously on. Okay. Now similarly for y1, focus on output 1. So 0 1, that is here b, and a is in normally close. A is in normally close, and same again y1, y1. So I can say that this is my, here is A. So this is my ladder diagram for the given example. Now this example I can write it like this. Just focus here y0 and y1. So first is 0 0. First two inputs are 0 0. So the outputs are also 0. Now when I am pressing a push button A, that is 1, that time my y0 output is on. If you check the second condition in table, 1 0, the output is 1 0. Now when I am releasing the A, button A, that is 0, my output will remain same. My output will remain same. Okay. Now again if you check this 0 1 means A is already 0, B became 1 from 0 to 1, that is B is pressed. Okay, when B is pressed, this y0 became 0 and this y1 became 1. y1 became 1. Okay, and when both are 1 1, both are 1 1, that is b is already 1, so you are going to accept, or you are going to make a 1. Okay, so that time y0 is 0 as it is hoga, and the y1 which is 1 became 0, means it will be off. So this way you can, yes, this way you can check the ladder diagram also, or you can draw the ladder diagram. Okay, so this is the second way. The next, yeah, so till time we have implemented a ladder diagram for simple designs, digital designs. Okay, but basically the PLC programming is used to program some real-time applications. So here some given real-time applications are, we have a 3 inputs and 3 outputs. Okay, if user press first output, last two outputs are on. So check karo first one. If user press I0, that is first IO, then last two outputs are on, that is Q1 and Q2 is on. Similarly, second case, second IO, if user press, that is before that just remember, on releasing the same output will be there. So on releasing of I0 it is 0, so 0 0 0, the same output, that is 1 1 is there. Now second case, second IO, that is I1 is pressed, then first and last output is on, that is first and last output is on. This first and last output is on. Again the same, on releasing same output, on releasing same output. Then third IO, if I press third IO, here first and second is on, first and second output is on. Similarly, first and second IO at a time, so first and second IO at a time, last output is on. Similarly, you can write down the basic truth table of a given example, okay. Now the simple way is, just a second, I'll erase all these things so that we'll get a better idea. Yeah, so here what we are going to do, we are going to focus on output 1. We are going to focus on output which is 1. So here and here, here and here. Okay, now if you see in first, when I1 is 1, Q0 is 1. When I1 I have released, Q0 is remain 1, remain 1. So here I can draw this diagram here. So first is Y0 or Q0. Okay, so I1 is open, normally open. Then if you see here, I0 is 1, so I0, sorry, I1, not I0, I1. Okay, so I1 is 1, Q0 is on. Q0 is on, and it after releasing I1, Q0 must be on position, that is Q0 is in latching. Okay. Now here if you see, when I1 and I2 is 1, that time Q0 is also I1 and I2 is 1, that time Q1 is 1. Okay. So just check, I1 is already there, so you no need to add I2 again, so that is a Q0. Similarly for Q1, these are the outputs. So here when I press I0, Q1 is on, and when I release I0, Q1 is as it is. So it is depend on I0. It is depend on I0. Okay. So I0 will be for Q1, and here Q1. So this is the Q1. Okay. Q0 and Q1. Now similarly for Q3, again here the common is I0. For common is I0. When you press I0, 1 is there. When I release I0, 1 is there. And when I am pressing I1, 1 is there. So what I can do? I0 and I1. I0 and I1. Okay? I0 and I1. And it will be continuously on. So Q3 is there. Q3 is there. Q3 is there. Okay? So this is the basic ladder diagram for a given. But now here we have more focus on only the output, which is 1. So when it is off, that we have to take care. When the output is going to off, that we have to take care, and that can be take care by just, for example, for Q0, here if you check 1 to 0. Okay, output is became 1 to 0 when I0 is pressed. When I0 is pressed. So here for Q0, I am going to write I0. I am going to write I0 in a closed loop. Similarly for Q1 it is I1. Similarly it is Q1 it is I1, and for Q2 it is I2. For Q2 it is I2. Okay. So I can say that this is the basic ladder diagram of PLC for given application. Now as an I can say homework part, or whatever you have to say, so everyone has to pause the video, just read out the given example and solve the example on your own. Okay. The solution will be provided shortly, but all students have to go through this given example, and you have to solve a ladder diagram. You have to solve a ladder diagram. Okay. So